All right, everyone, welcome back to AI Paper Podcasts. Today, we're doing a deep dive into a paper that's making waves in video generation. It's called Goku, Flow-Based Video Generative Foundation Models. Now, this paper, it's packed with technical details, but let's start with the headline for anyone short on time. Goku is a family of models that's achieving state-of-the-art performance in both image and video generation.
What's impressive is that we're seeing these advancements in open source projects. It's a testament to the work being done outside the big tech labs.
Absolutely. And the results, they speak for themselves. In benchmarks like GenEval and DPG Bench for text-to-image generation, Goku is scoring a remarkable 0.76 and 83.65 respectively. But what's even more exciting is its performance in text-to-video. It achieves a leading score of 84.85 on VBench, even outperforming some commercial models out there.
Those numbers are pretty mind-blowing, especially when you consider that video generation is still a relatively young field compared to image generation.
Exactly. And that's why we're taking a deep dive into this paper today. We're going to unpack what makes Goku so powerful. From the massive data set it was trained on, to the unique rectified flow technique that speeds up training. Plus, we'll check out some of those stunning results. Because seeing is believing right. So strap yourselves in because we're about to go deep into the world of Goku.
Okay, let's start with the foundation of any successful AI model, the data. Goku is trained on a truly massive data set, 36 million video text pairs and 160 million image text pairs. To put that in perspective, that's like feeding the model the entire Library of Congress, but in cat videos.
Hold on, more than just cat videos, I hope. But yeah, the sheer volume of data is impressive. But what really struck me is the meticulous way they curated it. They had this multi-stage filtering process, ensuring they were only training on high-quality data.
Right, because garbage in, garbage out, as they say. They filtered based on aesthetics, made sure the text matched the visual content, and even considered the motion in the videos. They really went above and beyond to ensure a clean and balanced data set.
It's like they were training a Michelin star chef. You can't expect culinary masterpieces with subpar ingredients. But what's really clever is how they tackled the challenge of video data. Being harder to acquire than images, they actually used images to improve video generation.
That's right. They trained on both image text and video text pairs, which allowed the model to leverage the abundance of image data to learn more effectively about visual concepts and relationships.
Okay, that makes sense. They're basically giving the model a crash course in visual literacy before diving into the complexities of video. Pretty smart. Now let's peek under the hood and look at the engine of this beast, the model architecture.
At its core, Goku utilizes a 3D joint image video VAE, or variational autoencoder. Think of it as a translator that can convert between the languages of images and videos. It allows Goku to handle both types of input and output seamlessly.
So it's like a bilingual AI that can fluently speak both image and video. I like that. But of course, we can't forget the transformer, the workhorse of modern AI.
Right. The transformer architecture is incredibly powerful for processing sequences, which is crucial for both images and videos. But given the massive scale of the data they were dealing with, they had to implement some clever optimization.
Ah, yes, optimization. The secret sauce of making these massive models actually work in the real world.
Right.
What tricks did they have up their sleeves?
Well, they used techniques like flash attention and sequence parallelism to make the training process more efficient. Flash attention essentially speeds up the way the model processes information within a sequence, while sequence parallelism allows them to distribute the workload across multiple GPUs.
So it's like having a team of super efficient chefs working in parallel to prepare a massive feast. Makes sense because training a model this big can't be easy.
It's definitely a computational challenge. And to make things even more robust, they implemented 3D Ropey position embedding, which basically helps the model understand the spatial relationships within the data.
Okay, so 3D Ropey is like the GPS of the model, helping it navigate the three-dimensional world of images and videos. I'm starting to get the picture, but I have to admit this is getting pretty complex.
It is, and to make matters even more challenging, training a model this large can be a bit like trying to herd cats. Things can get unstable, and you can end up with those dreaded loss spikes that disrupt the learning process.
Right, loss spikes. Those are like the kitchen fires that can ruin your perfectly good dish. How do they avoid that?
They implemented techniques like QK normalization, which helps to stabilize the training process and prevent those sudden drops in performance. It's like having a fire extinguisher on hand, just in case things get a little too heated in the AI kitchen.
All right, I think I'm starting to understand the foundation of Goku. They've got the ingredients, data, the Caption model architecture, and the safety measures, training optimizations, all figured out. But what about the the cooking process itself. That's where things get really interesting with Goku.
Yeah, the training process is where Goku really sets itself apart. They use a technique called Rectified flow, or RF, and it's different from the more common diffusion models you see in image and video generation.
Okay, so rectified flow sounds intriguing, but I'm drawing a blank. Can you break it down for me and our viewers?
Absolutely. Imagine you're sculpting a masterpiece from a block of marble. With diffusion models, you slowly chip away at the excess stone over many steps until you reveal the final form. RF, on the other hand, is like having a special tool. That allows you to reshape the marble more directly using linear interpolation. It's a more targeted and efficient approach that converges faster.
So instead of chipping away bit by bit, they're using a more sophisticated tool to get to the desired outcome faster. That's a great analogy, but does it actually work better in practice?
Well, they actually ran a pilot experiment, comparing RF to a diffusion model on ImageNet, a massive data set of labeled images, and guess what? The RF model achieved comparable or better results, with significantly fewer training steps.
That's impressive. So essentially achieving better results in less time. That's a huge win, especially when you're dealing with models and data sets of this magnitude. It's like comparing a master sculptor to a novice. The master can achieve the same level of detail with fewer strokes, thanks to their experience and technique.
Exactly. Now remember how we talked about Goku coming in 2 billion and 8 billion parameter versions? Well, training something that massive requires more than just a fancy algorithm. It needs serious computational infrastructure.
Yeah, we're talking about the equivalent of a Michelangelo studio, but for AI. What did they do to handle the sheer scale of this training process?
Think of it as a massive collaborative art project where each artist, or in this case GPU, has a specific role to play. They employed advanced parallelism strategies to distribute the workload across thousands of GPUs.
That's like having an army of sculptors all working on different parts of the same statue simultaneously, but coordinating that many GPUs can't be easy. There must be a lot of communication overhead, right?
Absolutely. To minimize that overhead, they used a technique called activation checkpointing. It's like having each sculptor only remember the essential details of their work and share those with others when needed, instead of constantly communicating every minute detail.
So they're basically optimizing the communication flow between the GPUs. To make the training process as smooth and efficient as possible. It's like having a well-oiled machine where each part works in harmony with the others.
Precisely, and to make sure they don't lose all their hard work if something goes wrong, like say a power outage. They implemented fault tolerance and efficient checkpointing using a system called byte checkpoint.
Okay, so byte checkpoint is like having regular backups of your sculpture in progress, so you don't have to start from scratch if there's an unexpected interruption. That's a crucial feature, especially when you're dealing with such a computationally intensive process.
It's like having an insurance policy for your AI training. But enough about the training process. Let's move on to the fun part, the results.
Yes, let's see what this Michelangelo of AI can actually create. First up, text-to-image generation Goku was tested on several benchmarks, including Generative T2i Comp Bench and DPG Bench, and it consistently outperformed the competition.
And remember how they focused on high-quality descriptive captions in their data? Well, it paid off. Goku excelled when given detailed prompts, demonstrating its ability to capture nuances and generate images that truly match the text.
So it's not just about understanding basic concepts, it's about translating those intricate descriptions into visually stunning images. It's like having an AI artist that can paint photorealistic pictures based on your words.
Exactly, and it's not just limited to static images. Let's move on to the text-to-video results where Goku truly shines. They achieved state-of-the-art performance on UCF 101, a dataset with a wide range of human actions, and blew other models, even commercial ones, out of the water on VBench.
VBench, if I recall correctly, measures not just the visual quality of the video, but also the smoothness of motion consistency of scenes, and how well the generated video aligns with the text prompt.
That's right, and Goku excelled in all these areas. It's not just about creating pretty pictures that move, it's about generating coherent and engaging videos that tell a story.
Okay, I'm definitely on the edge of my seat now. Let's see some of these videos in action.
All right, let's start with this one generated from the prompt. A flock of birds taking flight from a snow-covered forest. Notice the natural fluidity of the birds' movements, the way they interact with each other and the environment. The snow falling gently, the branches swaying in the wind. It's a beautifully composed and executed scene.
Wow, that's incredible. It looks so natural and realistic. You can almost feel the crisp winter air and hear the rustling of wings. And this one, a surfer riding a giant waves with the camera following from behind. Captures the energy and dynamism of the action perfectly. The spray of the water, the surfer's balance and control, it's breathtaking.
What I find particularly impressive is how Goku handles complex camera movements and perspectives. Remember that example we saw earlier of the astronaut running across the lunar surface, shot from a low angle? It's like having a virtual camera operator at your disposal, able to execute any shot you can imagine.
That opens up a whole new world of creative possibilities. And let's not forget the image-to-video capabilities. They were able to fine-tune Goku to animate still images using text prompts, adding another layer of creative potential.
Right, like that example of pirate ships battling on a swirling coffee cup. It's both surreal and visually stunning, and it speaks to the power of multimodal learning. Goku can take visual input, textual input, and combine them in novel and unexpected ways.
This is truly mind-blowing. Goku is a testament to how far AI research has come, and it gives us a glimpse into the future of content creation. But before we get too carried away with the possibilities, let's take a step back and consider the potential implications of this technology. Yeah, we've seen the benchmarks and witnessed some incredible examples of Goku's capabilities. But before we wrap up, let's dig a bit deeper into the implications of this level of video generation power.
That's a crucial point. We've marveled at the technical achievements, but now it's time to consider the so what. How might this technology reshape the landscape of content creation and beyond?
Exactly. It's easy to get caught up in the wow factor, but the real impact lies in how this technology is applied. What are some of the potential benefits you see, especially in fields like film education or even scientific visualization?
Well, imagine a world where filmmakers, educators, and researchers have access to tools that allow them to create high-quality video content with unprecedented ease and flexibility. Goku could democratize video production, empowering individuals and small teams to bring their visions to life without the need for large studios or expensive equipment.
It's like giving everyone a virtual Spielberg in their pocket. That could revolutionize independent filmmaking, online education, and even scientific communication. Imagine being able to create immersive educational videos tailored to individual learning styles, or generating complex scientific visualizations to aid research and discovery.
Precisely, and think about personalized media. Imagine creating custom videos tailored to individual preferences. This could lead to more engaging and effective marketing campaigns, personalized news feeds, or even interactive entertainment experiences.
Hold on, that sounds a bit Black Mirror-ish. What about the potential for misuse? Deepfakes propaganda, the spread of misinformation?
Those are valid concerns, and it's crucial to acknowledge the ethical implications of any powerful technology as AI-generated video content becomes more realistic and accessible. We need to develop safeguards and regulations to prevent its abuse. It's a double-edged sword, as many powerful technologies are.
It's like giving everyone access to a printing press. It can be used to spread knowledge and enlightenment, or to propagate harmful ideologies. It all comes down to how we use it.
Absolutely. The responsibility lies not just with the creators of these technologies, but with society as a whole, to use them ethically and thoughtfully.
So while we celebrate the incredible achievements of Goku and the advancements it represents, we must also engage in a thoughtful discussion about the ethical considerations and potential risks associated with this technology.
Exactly. We need to consider the potential impact on employment, privacy, and the spread of misinformation. It's a conversation that needs to happen alongside the technological development.
Well said. It's clear that Goku represents a significant leap forward in AI video generation, and the possibilities are both exciting and daunting.
It's a reminder that we're living in an era of rapid technological advancement. And it's our responsibility to ensure that these advancements serve humanity in a positive and ethical way.
And that's a wrap on our deep dive into Goku. Thank you for joining us on this journey through the world of cutting-edge AI research. We hope you found it insightful and thought-provoking.
And as always, we encourage you to keep exploring the ever-evolving landscape of AI and to engage in critical discussions about its impact on our world.